My name is Sohaib Tahir, and I am a solutions architect at AWS in the state local government team. And my co-presenter, Brian Tracy, he's also a senior solutions architect in my team. And today we are going to talk about how you can simplify compliance, security, and governance and operations using Systems Manager. We'll take all the questions towards the end. We have a bit of the ground to cover, so please hold on to your questions. So let's get started. So a quick show of hands. How many people have used Systems Manager? Quite a few. How many people know about AWS Systems Manager? Very good. All right, so first thing first. So Systems Manager, which was formerly known as Amazon EC2 Systems Manager or Amazon Simple Systems Manager, is basically, it's a collection of capabilities for configuring and managing your Amazon EC2 instances, your on-prem resources, or any VM with the Systems Manager agent running on it. And you can do that at scale. You can do things like applying operating system patches or software patches. You can collect inventory data. You can build automation workflows like creating golden images, and so on with System Manager different features. And you can use Systems Manager Console, which is a new experience that we came up with last year. Or you can use CLI or SDK for Systems Manager as well. We also have AWS toolkit for PowerShell. You can also use that for using Systems Manager service. So Systems Manager basically helps you to reduce the time to detect and resolve your operational issues, and also maintain security and compliance. How you do it, you basically can group your resources in a logical manner using Systems Manager. And then you can gain insight into those resources, such as you can get operational metrics, operational alerts. You can get the API information about those resources. You can track and enforce configuration changes. And then basically, you can take either a proactive action or a reactive action using, again, System Manager features. And we'll talk through those throughout this session. All right, so moving on, System Managers has multiple components. I'll talk about some of them in detail in the later part, but just to give you a highlight, it has many of these features that you're seeing on the slide. One of the important component is Systems Manager document. So it's basically a set of instructions that you can use to execute commands or automation workflows or enforce policies, configuration policies. And then it has features like run command that can allow you to remotely execute commands or scripts as long as you have an agent on the machine. You can also configure something like maintenance windows for scheduling disruptive actions that you have to perform on your environment. All right, so let's dive deep into some of these features. So the first one I like to talk about is AWS Resource Group, which is a feature of a Systems Manager service. It basically allows you to group your resources logically based on a matching criteria, such as a tag. And you guys may know a tag is a key value pair, so you can just define a tag something like environment equal to production. Once you have this tag, you can query Systems Manager, and you can find all the resources within this particular environment, such as EC2 instances, EBS volumes, Lambda functions, RDS instances, and so on. You can also group your resources or building block of your applications together using resource groups, such as a front-end layer and then a back-end layer. And then you can, again, query them or execute actions against these resources using the resource group. Resource group is also dynamic. What I mean by that is basically, for example, if you have a resource group that has a bunch of EC2 instances in an auto-scaling group, auto-scaling can actually add and remove resources based on the criteria you define. And resource group is automatically going to update that. And you don't have to go and manually update your resource group. So again, if you have some action that you're running on your resource group, it will work just as fine, even if the auto-scaling group is adding or removing resources on the fly. The next feature that I like to talk about related to System Manager is built-in insights. So built-in insights is basically integration with other AWS services, such as AWS CloudTrail. So AWS CloudTrail is our API tracking and auditing service. So in Systems Manager allow you, through this feature, to basically find the API calls within the resource group. Similarly, you can also see AWS configuration changes on your resources using AWS config on your resource group. The other thing that is also built into this Insight dashboard is personal health dashboard that actually shows you the operational status of AWS services. You can also see that in single dashboard view. And similar is the case with AWS Trusted Advisor, which is our service that actually provides you recommendations on AWS practices around security, cost optimization, and performance optimization. So you can get all those recommendations in a summary in Systems Manager built-in Insight dashboard. All right, so moving on. So the next feature you can use when it comes to System Manager is building your operational dashboards. And you can build your operational dashboards using CloudWatch dashboards in Systems Manager console, basically. So you can build operational dashboards for your teams, let's say. For example, you can build operational dashboard for your networking team. Similarly, you can build your operational dashboard for maybe a storage team with the relevant metrics. You can, if you are already using CloudWatch metrics, maybe custom CloudWatch metrics such as memory utilization, you can also bring them in this dashboard, and you can make it part of your operational process. Similar is the case with leveraging your existing CloudWatch metrics. And it's not just about infrastructure level metrics. You can also include your application metrics. All right, so the next feature I like to talk about is inventory and compliance. You can build your software catalog using inventory feature of Systems Manager. You can track operating system version, application version, software version. You can even track folders and files and permissions using inventory feature. And once you have built this software catalog, you can define what you consider to be a compliant behavior. And then you can create compliance rules using maybe existing scripts or maybe PowerShell scripts, even shell scripts, or something like Ansible. I'm going to show you a demo about Ansible later in the presentation. But you can use your existing tools as well to build those compliant rules. And then the System Manager console can actually show you if your resources are compliant or not against these rules. One of the third-party tool that you can use to build compliance rules is basically Chef Inspect. You can also use, if you're using it today, and bring those rules maybe through GitHub or Amazon S3 into System Manager so that it can check your resources against those Chef Inspect compliance rules. Once you have collected all this data, what you can do is you can actually push all this data into maybe a central S3 bucket. So think about this from a central IT perspective. For example, if you are a central IT and if you want to build a governance model, you may have other agencies that you want to enforce a compliance policy on that. You can basically use resource data sync feature to collect all the inventory and compliance data from those sub-agencies and collect them in central IT bucket, S3 bucket. And then you can use your third-party analytical tools, or you can use AWS services like Amazon Athena or Amazon QuickSight to basically see if they are compliant or not, and then enforce compliance from there. All right, so this was all about the insights that you can have into your resources. But once you have the insight, what do you need to do about that data, or how you want to take the action? So there are two ways to take actions. You can either take a reactive action or you can take a proactive action. When it comes to reactive action, it's normally to mitigate ongoing issues after the fact. And we have a bunch of services in Systems Manager that can allow you to do that, such as run command. We'll talk about automation over here. So automation is a very powerful feature of System Manager. You can basically write entire workflow in a Systems Manager document, which is kind of repetitive, or maybe it has sequential steps that you perform on daily basis. You can convert that into a Systems Manager automation document and input that to automation feature, and then it can execute it, and it can do that automatically based on the schedule you define through a maintenance window, or you can also trigger that automation document as a result of some operational event or compliance event. You can also write your own automation documents, and you can publish them in GitHub so that it can be used by community. The other thing automation provide is stepwise execution. So if you want to see how your each of the step is performing, or if you want to track the individual step, you can also do so with automation. And then you can also include approvals. So for example, if at some point in time your automation workflow is going to launch an EC2 instance, you can include an approval condition. So it will go and it will get maybe approval from an admin, and then it will execute that launch instance API. So you can do things like that with automation as well. And then, for example, the other thing which is pretty cool about automation is that, for example, if I am a user, I don't have permission to create maybe CloudFormation stack using automation, but my admin has it, so or I have a role that allows it to do it. I can delegate access, temporary access through automation as well. So in short, you can do different kind of things with automation. Some of the example use cases are you can basically automate the process of creation a golden image. You can automate the process of recovering an unrepairable or inaccessible instance. You can create an automation document for, and these automation documents are already existing, so you can use them, you can build on top of them depending on your requirements. And then you can meet your compliance and operational needs like that. The other good feature that you can leverage is the velocity control or rate control or error thresholds that you can define within your automation workflow. So for example, if you have 100 instances, both on-prem and EC2, and you want to apply your automation on a bunch of them, maybe 25% of them, you can use automation rate control to do that. And you can also define the error threshold in case if one of the steps fail in your execution, it can stop the automation workflow, and you can go and you can troubleshoot. And you can also get notifications, SNS notifications, so that you can go and you can look into if there is a failure or something. All right, and automation absolutely works on resource groups that I was explaining earlier. So if you have defined your environments in terms of tags, like production environment, or in terms of layers, like front-end, back-end layer, you can execute automation workflow against those resource groups. All right, so that was a reactive action. So you can also do proactive actions which can improve your day-to-day operations using Systems Manager, such as you can deploy operating system patches. You can enforce configuration so that you can prevent configuration drifts. You can store your secrets or data, such as database username password in parameter store. So all these things can improve your day-to-day operations, and we have a bunch of features in Systems Manager that can allow you to do so. The first one that I like to talk about here is Patch Manager. So Patch Manager basically allows you to select and deploy operating system patches, operating system and software patches both, on either EC2 instances or on-prem resources. So how you do it, so first of all, you would have to create what we call a patch baseline. So patch baseline includes rules for auto-approval of selected patches, and you can also define the delay in that auto-approval in terms of number of days. And if you want to override your auto-approval rules, you can also specify approved or rejected patches from those list of patches, such as operating system patches or security patches. So how to use it? It's pretty straightforward. So first of all, you would have to create what I just defined as patch baseline. You define your rules, patch rules. You define your the patch rule would include the severity of the patches, like critical or medium level critical, and then you can also define what kind of patches they are, maybe operating system or software patches. And then you have to put your resources in a tag, what we call a patch group. And then you can create a maintenance window when you will schedule for this patch deployment so that it can recurringly get deployed without you without you requiring to do any kind of intervention. All right, so the next feature of System Manager that I like to talk about is State Manager. So State Manager allows you to basically define and maintain consistent operating system configurations. What I mean by that is you can define a configuration policy based on maybe a shell script or Ansible playbook and feed it into State Manager. It is going to execute that based on, again, your defined schedule. And then it will also prevent drift. So if it detects a drift in the next run, it is going to revert all the changes that were made out of the band. And you can also monitor the changes on your instances or your resources through Systems Manager API. And you can also view what resources are compliant to your configuration policy and what are not. And then you can take actions as well if you want to. Otherwise, State Manager will automatically bring them or make them follow the configuration that you have defined in your State Manager workflow. OK, so here are a few use cases. Basically, we have a bunch of blog posts out there that you can go and implement yourself. And in this presentation, we are demoing a couple of those. So one of the ones that I am going to demo later is basically running Ansible playbooks using State Manager. I haven't implemented the run command, but it's pretty straightforward. You can do it yourself as well. So what we are going to do in this demo or what is happening in this blog post, basically, we are going to configure our EC2 instances and maybe hybrid environments. When I say hybrid environments, it can be EC2 instances, maybe running in some other AWS account, or they can be on-prem resources as well. So we are going to execute what we call AWS Run Ansible Playbook document. That is going to install an Apache server on various Linux distributions, such as Red Hat and Amazon Linux. And these instances will be running as SSM, Systems Manager agent. And then State Manager is going to enforce the configuration, and it will also prevent any drift that happens out of band. So let's see how it works through a demo.
We are looking at the EC2 console where we have two instances. One is Amazon Linux instance, the other one is Red Hat Enterprise Linux instance. The first step is for us to install Ansible module on both of these instances. I'm going to show how to install Ansible module using run command on Amazon Linux instance. Now we will go to AWS Systems Manager console. Under actions, we will hit run command. Here we will select the appropriate run command document. In our case, it's the AWS run shell script. We'll select that. And we will select our target instance, which is Amazon Linux in this case. And we will copy the command that we want to execute. In this case, we want to install Ansible. We can change the working directory, but we will leave it as is. And we will also leave rest of the parameters to default settings. One of the important features of run command is rate control, where you can define how many servers execute the command. You can define that in terms of a number or a percentage. In addition, you can define error threshold in case a command fails. And you can configure SNS notifications. We also generate a CLI command for you to execute. Now we will hit run. Here you can see the command was successfully executed. Now we will go and look at the output of the command. In the output, we can see the messages that were generated during the execution time. Let's take a look at our managed instances. Here we are seeing three instances. The first one is the one that we just configured. The second one is a pre-configured Red Hat instance. And the third one is actually an instance from a different AWS account that is being managed by this account using activation. Our goal is to execute Ansible playbook against all these three instances using State Manager Association. I'll go back to the EC2 console. I've associated operating system tag to all of my EC2 instances with a value of Linux. I'm going to use this tag in State Manager Association. I'll go back to Systems Manager. I'll create a State Manager Association. I'll give it a name, and I'll select the Run Ansible playbook from the document list. The next step is to copy the playbook from the blog post that I have been using. This script is responsible for installing an Apache server and then starting it. I'll copy the playbook here and I'll make sure that there are no syntax errors. The next step is to select the instances. I can do that manually. I can select each of those instances one by one, or I can use the tag that I was showing earlier, which was operating system tag. The next step is to select a cron schedule. I can build a cron schedule or I can write an expression. I'll select 30 minutes cron schedule and I'll create an association. Once I refresh the page, the association has been successfully created. I'll go into the association and I should see all the instances that are part of this association based on the operating system tag. I'll go into one of those instances to find more information about it, and through this page you can find information like inventory. If you would have configured that on the instance, you can find all the tags associated with the instance. You can find associations that it is part of, the patch information, and the configuration compliance. I'll switch back to the EC2 console and I'll double check that the Apache service is running on both of these instances. As the next step, I'm going to SSH into one of my Linux box and stop the service. So I'll go back to the EC2 console, I'll open a terminal and I'll SSH into the instance using the IP address from the EC2 console. I could have used run command to stop the Apache service as well. I'll verify the status of the service. It's running. Now I'll stop it. And I'll refresh the page to make sure that the service is not running anymore. I'll go back to Systems Manager console again and apply the association to refresh it. Please note that you would not need to reapply the association since we already have defined a cron schedule. On refreshing the page, I can now see that the Apache has been restarted.
All right, so you saw that it's really easy to set up a state manager. We were able to execute Ansible playbook. So it basically complements your Ansible scripts if you have them. And we also looked at the velocity and error control feature of State Manager and how you can use it for multiple AWS accounts and hybrid environments. And one important point to note is that there is no additional charge for using Systems Manager. So you can easily complement it with configuration management tools like Ansible or Salt or Chef. All right, moving on. So the other blog post that actually I wrote this year is central IT governance model. So we actually worked with one of our state level customers, and they had basically AWS account for the central IT, and then they had child accounts for all the other agencies, and they wanted to basically build a governance model where they can enforce patching and golden images through a central IT account. So in this solution, what we were able to do is we were able to create a central IT account for the central IT agency, and then we created sandbox account, sandbox prod and dev account for the other agencies, and all of them were actually registered to the central IT account using what we call Systems Manager activation. And then all the concepts that I was talking about earlier, like patch manager, state manager, automation, and We were able to apply that using tags on all these resources running in agency accounts. At this point, I'll turn it over to Brian Tracy to talk through password rotation for Windows instances.
Thank you, Sohaib.
Thank you.
Good afternoon, everybody. As Sohaib said, my name is Brian Tracy, and I'm here to talk to you today about password rotation for Windows instances and automating that with EC2 Rescue. This is a solution that I've implemented at numerous state-level agencies across the Eastern Seaboard. So the question is, why do we do this? So you're probably already familiar with the fact that AWS uses key pairs when you stand up an instance to be able to give you access to those resources. And what that means with Windows servers specifically is you essentially decrypt the local administrator's password using that key pair. After that, agencies typically either join those instances to domains and utilize their AD credentials to access those systems, or they create local users on that box. Those agencies also typically have password rotation policies such that users are forced to rotate their passwords. I know you all have endured that probably numerous times throughout the year, sometimes painfully. And usually those policies say, okay, look, if Sohaib didn't rotate his password in the last 60 or 90 days, he's got 3 days to do it, or I'm locking him out of the system. And those policies work pretty effectively. What they overlook in a lot of cases is the local administrator's password. That account typically isn't getting used very heavily. Those credentials are typically owned by a small group of people who sort of say, look, our team is pretty secure and we don't have to rotate those on a regular basis. So it gets overlooked. The problem with that is for specific workloads that have compliance regulations attached to them, it causes you to be out of compliance with those workloads. So one of the agencies that I've done this for recently had a HIPAA workload, and this was causing them to be out of compliance with their local administrative account password rotation. They didn't have the cycles to do it, they didn't have the team to do it, and they had numerous servers on which they had to do. So as Sohaib has already said, there's no additional charge for this service. I'm a huge fan of automation because I can't quantify how many times I've had good intentions and hit wrong keys. So the idea here is let me help this state agency automate this for them, and keep them in compliance. So Sohaib's already covered things like what an systems manager document is. Just to quickly rehash that, it's a set of instructions, right? So it's a PowerShell script or a Bash script that has steps and instructions of what you intend to do on those servers. This particular one that we're going to talk about today is called AWS Support Run EC2 Rescue for Windows tool. And the password rotation is one element that we're going to talk about today, but in fact this tool has numerous other use cases available to you with capabilities that are very worthwhile. This particular one will use KMS keys to essentially cycle the local administrator's password and then store it safely in the Systems Manager parameter store. Really nice, requires no downtime, requires no system reboots. Sohaib elaborated a little bit earlier about the requirement to have a Systems Manager agent already running on those machines. And you can do that both in AWS and in on-prem servers or in other cloud provider servers as well, right? It's a simple agent load. You configure the Systems Manager maintenance windows that he also talked about earlier. My demo video will go into a little more depth about how to do that. And essentially, what I've done in my demo to set this up a little bit is in my past life of 20 odd years, we'll just leave it at 20 odd years, of software development has been that different administrative teams typically give different levels of access, whether it's development, test, QA, staging, production. In my very simple example here today, I've created development servers and production servers, and I've used 2 different KMS keys to allow people with the development permissions to access those passwords to those instances, and people with the production role to access those instances. So next we will go to the demo.
Starting in our EC2 console, you'll see that I have 3 production instances and 3 development instances. We use tags, a key value pair, to indicate which environment each instance is a member of, for either production or development, as you see here as I click through each of those instances, the value changing from production to development. Clicking on the Description tab, I want to scroll down and point out that each instance has an EC2 role attached to it, which grants permissions for this systems manager, and no key pair provided in instance creation, which means that these instances won't be able to have their administrative password decrypted by default. Shifting to the systems manager and now clicking down on the managed instances section, you'll see those same 6 instances, 3 production and 3 development. This is possible because they're running the Systems Manager agent on those Windows operating systems, and they automatically get registered as managed instances in Systems Manager. If we look at the tags within Systems Manager, you'll see the same environment key and a value for either production or development on those instances. I've created 2 maintenance windows, one for development and the other for production, so that I can manage those password changes independently. The Description tab shows some details about the maintenance window, such as a small description for it, a cron expression for how often you'd like it to run, and the duration of the maintenance window. Clicking the Targets tab, you'll see the targets that I previously registered for this, in this case the development environment. Clicking into that, you'll see how I accomplished that. I gave it a name and a small description, and then I used those tags that we created on the EC2 instances earlier to define the environment, and in this case, development. Clicking into the tasks part of the maintenance window, I want to highlight the AWS managed document that's used to control the task. Scrolling down to the managed documents that you see here and going to page 3, you'll see an AWS support run EC2 rescue for Windows tool document. Scrolling a bit further, you see the targets that we've previously identified, in this case for the development environment. And scrolling down a bit further, you see the role associated with this maintenance window. We'll talk more about that role soon. And finally, the parameters. Now, this document has a number of different capabilities. Resetting access is the one that we're going to focus on today. And then the parameter. And the parameter is the ID of the KMS key that you want to encrypt the rotated password. Back to that role that the maintenance window uses. It's simply an IAM role using a managed Amazon role for maintenance windows. If we look at the encryption keys used in this solution, you'll see that my administrative account doesn't have access to these keys. So we're going to change roles to one that does have access. Now you see the Allow Decrypt Production Windows role has access to that production key. Switching to the development role now has access to the development key. If we go back to the Systems Manager console, you can see that those keys are secured as secure strings, and when I try to show the value of the encrypted string, I get this error because my admin user doesn't have permissions to use that encryption key. Switching to the Decrypt Production Windows role allows me to then decrypt that production key. The History tab will show you the history of versions that have been rotated and give you the ability to decrypt them. If we go back to the parameter store and go down and identify a development password and try to access that using our Decrypt Production Windows role, you'll see that we also get a security error. Switching roles now to use a development Windows key, I can likewise decrypt that password.
Great. So, thankful for taped demos. I'm not a huge fan of live demos. So wrapping up what we just showed you was the total time it took me to set up that demo was approximately an hour. Estimated cost for solution, we've already talked about Systems Manager not costing anything additional from AWS. So that's a really powerful tool that we give you to be able to automate a lot of the capabilities within your organization at no additional cost. There was, theoretically, a slight charge for the KMS encryption keys that I utilized. KMS keys for custom keys are $1 per month. So in this example, because I used 2 different KMS keys for production and development, and if I let this run for a month, my total cost there would have been about $2. And with the KMS API, you get 20,000 requests each month as part of the free tier. Beyond that cost, it's about 3 cents per 10,000 requests. So for these 6 servers, 3 production, 3 development, I let this solution run in my account for about a week's time. And I was changing passwords in each of those instances every 2 hours. That's pretty excessive. I don't recommend that unless you're really concerned about password rotation. And I didn't even clear 1,000 API requests. So this solution was effectively, a rounding error in terms of additional costs. But the value that your organization can derive from it in terms of compliance with different regulations is invaluable. So what we covered today. So earlier in the talk, Sohaib gave you an overview of the Systems Manager service. He talked about a lot of stuff. We could have filled probably a whole day talking about the different capabilities and features inside of Systems Manager and how you might be able to leverage them. We talked about simplifying operations for compliance and governance. I think we were able to demonstrate to you some of the efficiencies and ease of use. I know this presentation is very quick. It is available after the summit, and certainly we'll provide our contact information as well. And I think it also showed how you can handle fleet-wide management of your resources in an efficient and economical way. So there are a lot of other use cases that we didn't cover today. Sohaib did talk a little bit about system inventory and patch management, as well as the hybrid environments. I touched on earlier that our definition of hybrid environment is AWS and any other environment, whether that's your on-prem environment or whether that's you have resources in other cloud providers. All that is capable, and installing and removing software. The key message that I have for you here is we have a bunch of predefined system managers documents that will help you do a lot of things, but not all of them may be documented and written to help you solve the problems that you may be trying to solve in your own organizations. So if you don't have a document that can help you do that, write one. Sohaib also mentioned earlier, Systems Manager is available out on GitHub and it's open source. While you don't have to share any documents that you write with the open source community, it's certainly favorable to do so. So before I call Sohaib up onto the stage to help answer any questions that you might have, one question I would ask of you in the room, he asked earlier how many people are using it or have heard about it. So after our discussion today, what I'd sort of like to get a feel for is how many of you intend to go out and kick the tires on Systems Manager and see what it might be able to do for your organization? Great, so I'm gonna sort of take a rough guess and say that was more than when we started, and so that puts a smile on my face. Can we answer any questions for you? Yes, sir.
Hi. Is there any plan for the agent to be to support iOS?
So generally, we don't talk about future enhancements to the service. Having said that, I'm not aware of that at the moment, but that's certainly a possibility. One of the things that I think is very important to point out here, and it's before my next slide, is that feedback from customers like yourself really help drive 90 to 95% of our product roadmap. So if that is of need to you, then let's work together to submit what we call a PFR, product feature request, and get that in front of our service teams. Any other questions? Sorry, it's hard to see people. Sir?
Can you come to the
Can
mic?
you just step to the microphone, please?
The install of Ansible, was it agent-based or agentless?
So you have to have a systems manager agent running on the machine to execute Ansible playbooks.
No, but like on your demo, you also installed Ansible. The Ansible itself, was it agent-based
So
Ansible or agent-less?
It can be either.
It can be either.
Yeah.
Okay, good to know.
No other questions? So we'll be outside for some time if anybody has additional questions and want to talk about Systems Manager. Thank you so much for your time. And as I mentioned earlier, we generate a lot of our roadmap and capabilities based on your input, so please also fill out your surveys for today. Thank you.
Thank you.